So the first thing is what MATLAB. MATLAB is simply matrix lab. It's like, just like an acronym for math, matrix, then laboratory. And it's not just an acronym, it's a programming language, and it's one of the most widely used programming language for technical and scientific computing. And the reason why it's widely used is due to the fact that it has been designed to optimize matrix manipulation. In other words, in MATLAB, you can process matrix or matrix objects in a very rapid and in a very efficient way. And the core of most scientific computing is matrix. At the core of most scientific computing, even machine learning and so on, is matrix. If you don't have a matrix library, you can't do machine learning. You can't do so many things in science. Let's talk about what you can do with MATLAB. You can use MATLAB as a calculator. What I mean by that is I can just do some computation like 2 times 5. So I can do basic computation like this. I can solve, I can look for the sign of, let's say, 2.1. I can do all kinds of calculation. That's one thing you can do with MATLAB. Then another thing you can do with MATLAB is you can write a program, like you can write a full-scale program. And it's a program that you can write in almost any other programming language. So it's not just about you running stuff like this. You can write a full-scale program. I'm going to show you a program I wrote in MATLAB just to give you an idea of the level of complexity of what you can do. So what I'm trying to do is I'm trying to whet your appetite. I want to let you see that MATLAB is very sophisticated. So I'm trying to show you things that I've done with MATLAB to give you an idea of how sophisticated it is. So I built a Rubik's Cube simulator that can solve a Rubik's Cube problem. So I literally wrote all of this in MATLAB, both the graphics, both the buttons, and everything. So this is Rubik's Cube. I can rotate it in 3D. I can rotate it in 3D. All of this entire application you are seeing was built from scratch in MATLAB. Then let me try to shuffle it. So this whole application is in MATLAB. So this is just to give you an idea that you can do something really sophisticated in MATLAB. And of course, we may not get to this level of complexity, but this just lets you know that you can do much more. It's not all about all the basic stuff you see people do. So what else can we do with MATLAB? We can also model things. We can simulate problems with MATLAB. Then we can also integrate MATLAB with other languages. For example, MATLAB can be called from a C++ or C programming language and so on. So let's talk about the components of MATLAB. I'm going to start with the environment. I've talked about the language to an extent, but let me just talk about the environment. So here is a MATLAB environment. Here you have the command window. So here, if I say A equals 20, I'm running this within the command window. So this box where I'm typing stuff is the command window. Then on my left bottom side, you will see we have the workspace. So what's the workspace? The workspace is where you see all your declared variables. That is, all the variables you have declared so far. You will see them within the workspace. So let me create a new variable. Let's say C equals 12.6. You will notice that you now have a variable name called a variable name C, and the value is 12.6. So that's the namespace. Then which other section do we have? We have the current folder. The current folder is where any code, any script you are writing should be located within the current folder. If you don't have them in the current folder, MATLAB cannot locate them. So let's say I have a bunch of codes, and those codes are mine, that are not inbuilt. you need to have them within the current folder. So you have two options. Is either you copy and paste within the current folder or you change your current folder. That is, if my current folder is not where I am at the moment, I can change it. So how can I change it? I can simply browse for it. I can just click this browse button and browse for it, or I can, if you want to browse, you can go back. Let's say you want to go back by step, or you want to browse, or you want to pick from your history. You can pick from your history. So I already have a kind of history here. So I can pick from the history, and here we have it. Okay. So this is your current folder. It's very important to understand that current folder is where MATLAB will look at if you call a function that does not exist. That is, if you call a function that exists within MATLAB, it will run it. But if that function does not exist, you check your current folder to see if the script is there. If the script is there, it will run it. If the script is not there, it's going to fail. So let's say I have ABC, I just run this script, I pass it nothing. It's going to tell me that the function is not defined. But if I have a script that is named this way, it's going to run that script. And the location that MATLAB will check is your current folder. Okay, then there's another part which is called the history. The history. To talk about the history, I'm going to click on layout. Layout allows you to restructure the layout of command window, current folder, and workspace. You can shuffle them around. You can even remove them. If I don't want to see my workspace, I can uncheck it, and the workspace disappears. If I include the workspace, it comes back. Under the layout, I can include the history, the command history. The command history is where you can find all the commands you have been running for a while. So let's say you want to see all the commands you have been running. The command history tells you all of that. The good thing about the command history is you can see everything you've done. So which means while we are practicing on the command window, you don't need to save it. You don't need to save what you have on command window. You can just go to your history and see all that you've typed before. So command history is very good for recalling what you've done so far. Okay, so let's talk about data type. What do I mean by data type? Let me start with what they call primitive data type. Primitive data type are like the foundational data type, or you can call them the raw or the core data type, because every data in MATLAB must derive from the primitive data type. That is, all of them must originate from the primitive data type. So let's start with the primitive data type. So the first one I'm going to talk about is the double data type. When you hear the word double, like double refers to floating point numbers. So if I have 12.4, that's double. In fact, in MATLAB, every number is assumed to be a double by default. So if I say ET equals 25, even though this ET is a whole number, MATLAB is going to treat it as a double. That is, the class of this number is double. So what's double again? Double simply means a decimal number. That is what it means in MATLAB. Any number that can have both whole number side, decimal part, a negative and positive, that's double. How do you know if a number is double? If you check for the class of that number, so let's say class of D, you can see it displayed double. Double is the class. If I say class of ET, even though ET is whole number, it is still going to be treated as double. I hope this is clear. Like, I believe what I've just said is very clear. So the next is integer. We have data type that are integer, just the way we understand integer, that's whole number, both negative or positive whole numbers. But the problem is, if you just type any whole number, MATLAB treats it as double. So for you to explicitly tell MATLAB that this is integer, you have to do extra work. So you have to do something like, let's say int 32 brackets, let's say 12. Now let's check the class of T. So the class is int 32. We have different ints. We have int 32, we have int 64, we have int 8, we have int 16. So let's talk about string. If you want to define a string, you have to start with a quote. So here's the idea here. Imagine you want to tell MATLAB to represent a name of somebody, not a number. How do you do that? You have to represent it as a string. So in MATLAB, you call it string or character. Like if I ask for the class of this, the class is char, which is short form for character. So now the question in your mind is, what is character? How is it different from what we've been talking about, double, int, and so on? A character is just a data type that just combines characters. Like it's just a combination of characters. There is nothing like magnitude. Magnitude meaning you can't say this character is 1 billion or 100,000. It's all about collecting characters. It's a collection of characters, string of characters. So let's take a look at this. If I type this, and I type this, which of them is character and which of them, between HG and FG, which is character, which is double? Mind you, they are not the same, even though it appears they are the same. If you check, both of them, they have 1, 2, 3, 4, 5. It may appear they are the same, but they are not the same in the sense that the operation you can perform on FG, you can't perform it on GH. The reason is GH is just a combination of characters. MATLAB does not know whether it is 1, 2. All it knows is you are just aggregating character. So if you perform an operation like GH times 2, do you see the result is weird? Like we did GH times 2. Look at what we got. Like it doesn't make any sense. Like I multiplied a string of 1, 2, 3, 4, 5 by 2, and I got a bunch of numbers that I don't understand how they relate. Whereas if I multiply FG by 2, it makes sense. Like 1, 2, 3, 4, 5 times 2 will give me 24,690. Do you understand? Now, the point I'm stressing is you need to clearly know that strings are different from doubles or numbers. The reason is they have different operation. The way you manipulate a string is different from the way you manipulate a double. And the reason for that is strings are a bunch of characters. So when you are manipulating them, you manipulate them like a bunch of characters. So for instance, so let's say I have this is John. I've defined a name as John. If I want to convert John to uppercase, I can do that on a string. I believe you can see that everything is now uppercase. But you can't perform uppercase on a number. It doesn't make any sense. Like uppercase on a number, what do you get? It doesn't make any sense. You get my point? Like uppercase on a number does not make any sense. But uppercase on a string makes a lot of sense. Hope you understand my point. So strings are treated like a bunch of numbers, and when you operate them, you're operating them as if you are manipulating each character. So we'll talk about string manipulation later on in the class. So this is a string. So let's talk about the next data type, which is Boolean. So Boolean is just a bunch of true or false statements. So if I have true is a Boolean, then if I have false, this is also Boolean. So in other words, Boolean is all about 1 and 0. So the true is equivalent to 1. The false is equivalent to 0. So let's take a look at the class of B. So the class is logical. So Boolean in MATLAB is known as logical. So whenever you hear things like logical data, all they are saying is Boolean data. Is a matter of 0 or 1. 0 is false, 1 is true. Okay, so these are the primitives. So let me recap again. We have double, we have integer, we have strings, then we have the Boolean, the true or false, the logical. Okay, now let's talk about the arrays. Let's talk about arrays. Arrays are groups of data. So they could be groups of all this primitive data. So if you have a collection of primitive data or a collection of other data, you call that array. But now in MATLAB context, an array could be either a vector or a matrix. So let's talk about the vector. So vector, let me just say VT. Let's look at an example of a vector. So 1, 2, 4, 8. This is a vector. So a vector is an array with one dimension. So if I have just one row or one column, then I have a vector. So let me look at VT2. There's something I would like you to observe here. So let's take a look at the difference between, can you check out the difference between VT and VT1? Okay, there's something I need to throw here. How do you define a variable name? VT is a variable name. VT1 is a variable name. Then the value I'm assigning to them are in front of them. That is, on the left-hand side, you have the variable name. On the right-hand side, you have the value assigned to them. I believe this is clear. So note that variable names cannot contain non-alphanumeric. For example, I can't use I can't say hash sign with D equals 12. It won't work. That is, a variable name must either contain a letter followed by, let's say, a number, then followed by underscore. You can have underscore letters or numbers as variable names. You can't have any other character. Then a variable cannot start with a number. It must start with a letter. So I can't say 1D. It doesn't work that way. You understand? But I can say D1. So these are another points I need to mention, because when defining variable names, if you don't do it the right way, you get an error. So let's move on to vector. So this is VT. So let's say VT is 1, 2, 3, 4, 5, and VT2 is 1, 3, 6, 9. Now I'm going to use colon instead of comma. Colon instead of comma. So which of them is row? We have two types of vector. We have row vector and column vector. So which of them is row vector? Which of them is column vector? Is it VT? Is VT row vector or column vector? You need to understand the difference, because at some point you will need to be transposing things. So a row vector is one that has just one row. So the way MATLAB represents data is this. A row is on the horizontal axis. The column is on the vertical axis. So if I want to create a row, I simply separate by comma. That is, if I have 1, 2, comma or space. So I can have something like space. I can have 1 space, 3 space, 5 space, 7. It's also going to work. Then I can have commas in between. It is going to work. Do you understand? So space, commas, any of them will work. This a row vector. If you want to create columns, you have to separate by semicolon. So semicolon will give you the columns. So if you do this, you are going to get a column vector. Each of them, they are known as vectors, whether row vectors or column vectors. They have just one dimension. Either they have horizontal dimension or vertical dimension, just one dimension. So the next is matrix. How do you create matrix? So let's say MT1, that's matrix 1. Let's say I want to create this matrix 4, 6, and 7, 9. So here you have a matrix. In this matrix, we have 3 rows and 2 columns. Here you have the first row, second row, third row. The question is, how did I create it? So let me just walk you through how I did. the first row you separate by comma, then you end with a semicolon. Then when you end with a semicolon, you're about to start the second row. Then you type second row, then you end with semicolon, then you type the second row, then you keep doing that. So it's very straightforward. You type the first row, you end with semicolon, you type the second row, you end with semicolon, and you keep doing that until you are done. Also note that you can't have you can't have inconsistent dimension, which means you can't have the first row having 2 columns, second row having 2 columns, third row having 3 columns. If you do that, MATLAB will tell you that you are doing something else. So that is, you're going to get an error telling you that dimension of matrix being concatenated are not consistent. So this means if you have 3 columns in the first row, you need to have 3 columns in the second row and 3 columns in the third row. So you have to be consistent in your number of columns for each row. Okay, so let's go back to the original state. So this is a matrix. So now what can you do with matrix? Let's ask questions like, how do I know the size of a matrix or the dimension of a matrix? If you check for size, like if I say size of MT1, you are going to get 3, 2. Now what's 3, 2? 3 means 3 rows, 2 means 2 columns. I believe this is clear. If you check this matrix, that's 3 rows and 2 columns. What about calling length? There's another function called length. Note again that every time I call a function, I put in a bracket, then I pass in an input. So that is the format. Every time you call a function that requires an input, you must put it in a bracket. So what's length? Length is the maximum value of the size. What that means is, when you take the size, the dimension, the longest dimension is the length. So don't think that length is always referring to the number of rows. No, length is not always number of rows. Length refers to the dimension with the highest number. So if the row has the highest number, the length will be the row. If it's a column, then the column will be the length. So length is always going for the highest. So if I have 5 rows, 10 columns, columns will be the length. So the answer, let me give you an example. So let me come up with a random matrix. So let me just call this magic function to give me some random matrix. Okay, let me not call this random. Let me choose something else. Something like ones. 10 row and okay, let me choose 5 and 10. Okay, so here we have 5 rows and 10 columns, and everything is just made up of 1. This is a special function in MATLAB that allows you to create a matrix of ones. So that's what ones is all about. Let's look for the length. So the length will be
10,
the longest. Whereas if I have 10, 4, or let me say 6, 4, and I look for the length will be 6. So length is always going for the longest dimension. It's as simple as that. Okay, so the next is, what is structure meant for? Structure is designed for a case where you want to have sub-variable inside a variable. So sub-variable means you have a main variable, but inside that main variable, you want it to have another variable name inside. So let me give you a typical example where you can use structure. So let's say you want a data type that can store a student's information or biodata at once, and you want it to store it in a very descriptive fashion. Structure is just the best for that. So to create a structure, you can create a structure by calling struct. Like I can call struct. Then inside struct is like the function for creating structured data type. So the first thing you want to do is you want to type the name of that property. We call this the key of that property or the name of that property. Then let's say the name of that student is James. The score of that student is 79. Then let's say the gender is, let's say, male. Then let's say the class, the level is level, let's say 200. So now I've created a structured data type. So take a look at the output. If you check the output, it has a name component, score component, gender component, level component. So structure allows you to create a kind of data that you can access each component with a dot. So I can say data, that's dat.name. What's the name? I can say dat. I just want to get the score. Do you get the point? In other words, inside dat, you have sub data inside. A single variable is now holding many variables. Do you understand? Like, it's like you saying name, score, gender, level, they are all encapsulated inside data. By encapsulating it, it means if you are moving data around that dat, that single variable name, you have access to all the other variables. So you don't need to keep track of all the other variables separately. Inside dat, all the other variables are inside. And the same rules that applies to variable also applies to struct, which means I can't have some weird, what I mean is I can't have, I can't call something with hash or something like this, hash and all of that inside. So when you create a struct data type, be mindful of, okay, let me create another one for instance. So let's say I want to capture things like a student's score in each subject. So I want to say English, the person scored 60, maths, the person scored, let's say 70, and let's say physics, the person scored, let's say 80. Now, let me now say I want to add a variable that is weird. Maybe the variable has minus, plus, A, B, C, and this sign. Then let me give it any number I want to. Now, if you check this, it said invalid field name. I believe you can see the error. So it means your field name must satisfy the same condition as your variable name. Hope you understand. So like if you can't use all these characters for your variable name, you can't use them for your field name. Hope is clear. So this is the right way to represent it. So inside DAT1, I can access the physics, I can access the chemistry and so on. And to access each of those sub variables, you will use a dot to access them. Okay, so that is a structured data type. You may be asking, when do we use this kind of thing? You use it when you want to organize data that do have heading. If I have a data with heading, so for example, you can have a data from Excel or let's say I have a data from Excel that has the following structure. So let's say I have a data like names, and under names, I have a kind of an array of names. Do you understand? Like an array of names. Let me use this to represent my array of name. Okay, I want to explain this aspect because I will need to talk about structure, cell. Let me talk about numbers first. So let's say I have a list of scores for a particular class. Let's say I happen to be a class teacher and I'm collating all their scores. So here is what I can do with structure. I can just have a list of all the scores in English. So this is 60, 50, this is 85, let's say 90, 100. So the next is, let's say mathematics. I have an array of how many do I have? 1, 2, 3, 4, 5. 1, 2, 3, 4. Then I have 5. Okay, so this is one way to represent. So imagine I have a data from Excel where English represents the colon name, maths colon name, but this represents the value in the cell for that colon. Struct allows you to encapsulate all of that information in one data, in one variable. So if I want to get data for colon 1, I will just say data 1 dot. You just call the name of that field name. We call English the field. Like English, math, they are the field name. They are the field names. So you can access the data corresponding to the field by typing dot the field name. Then if you want to get a list of all the field names at once, you can just type field names, then data 1. It gives you all the field names. So let's say you don't know all the field names. Let's say somebody created it and passed the data to you. You can just call field names, pass in the name of that variable. It will give you all the field names. So that's structure for you. So we're going to use them as we go along. But this is just to give an idea of what you can do with structure. Structure is not an array per se. It's just a way by which you combine field name and data. The data can be anything. So the data can be a matrix. The field name must follow the same rule as a variable name. You understand? That is, a variable name has a rule. You have to follow that when defining the field name. Then I can also include another field. So let's say I've created data 1. I want to add more fields. So let's say I want to add chemistry field. I can type chemistry and just keep typing, 50, 40, 90, 30, and let's say 100. And now I have chemistry as part of the list. So with struct, I can keep adding more stuff inside the data. If you want to create an empty struct, like an empty structured data type, just type struct without anything. Then it has empty data type. Then you can start typing stuff in it, like score equals 90, data 2 dots, let's say age equals, let's say 22, and so on. So you can build and you can start building from an empty struct and keep adding as you go along. So this is struct. So let's talk about cell. Note that all these things, they are very important because as you go along, you start getting to see them being used in reality. And the more you know about this, the better for you, because along the line, you will come across them in documentation and so on. And if you don't know what they mean, you'll just be lost. Okay, let's talk about cell. What is a cell data type? So let's have cell. Let me just create a simple cell. A cell is very similar to an array. The difference is the representation. The same way you define an array is the same way you define a cell. The difference is that you use a curly bracket. In the case of an array, we use a square bracket. Do you understand? I believe you can see the difference. The C1 is a cell. How do you know that is a cell? Just call the class, like class of C1 is a cell. C1 is a cell, whereas A1 is a double, like a collection of double, which is an array of double. So what's the difference between a cell and an array? By face value, like the difference, if you look at it, is just the curly bracket. So a cell has curly brackets, a matrix or an array has square bracket, whereas cell curly bracket. What's the other difference? The other difference is a cell can store any data type, a combination of any data type. So I can say, okay, cell 2, I want you to store my name. Then I want the next element to be my score. I want the next element to be let's say height, something like that, then enter. You see that you can store all kinds of things in cell. In fact, I can store an array inside an array with a struct inside. That is, I can say, okay, the first one is John. The second one is, let's say, a number. The third one is data 1. The fourth one is cell 2. I can store that same, the previous cell. Then, okay, then I can store a matrix. So I can store a matrix like this. Okay, so this is a cell. This means the difference between a cell and an array is an array must store homogeneous data. That is, an array is a collection of homogeneous data. That is, if I have a collection of numbers, it's an array. But a cell can store heterogeneous data. So I can store a string. The second element can be a number. The third can be another structure, can be another cell. In fact, it's like you just storing any data type within an array structure. You are using array structure to store heterogeneous data type. That's what a cell is all about. So this comes handy, like a cell comes handy where you want to store different things. You want to have a collection of different data type of different shapes and types and so on. So let me just recap what we've talked about. We've talked about double, integer, string, boolean. These are the primitives. Then we talked about array. Array is a collection of double. And if you have one dimension, we call that vector. If you have 2 dimensions, you call that matrix. If you have more than 2 dimensions, you call that multi-dimensional array. Then we have struct. Struct allows you to specify a kind of sub data type, more or less like field. You can define field and the value of that field. So struct allows you to do that. Then cell allows you to collect information like array. But this time around, you are collecting an array of heterogeneous data type. So you can have an array of string, you can have an array of string with number, with struct, all of them model up into one data. So that's what a cell does. So the next question is, how do we access data in array or data in cell? So to access a data in cell, so these are C1. How do I get the first element? The same thing goes to array. So let's talk about indexing here. So what I want to talk about is indexing. Indexing means if I have an array of numbers, so let's say I have an array of numbers like 1, 4, 8, then 3, 6, 9. How do I access 6? Like how do I access 6? To access 6, you need to specify the name of the variable, which is 82. Where is the colon number? Sorry, the row number. The row number is what? 6 is at row what?
2.
Then is at colon what? 2, right? Like
2.
Yeah. So when you click enter, it gives you 6. So how do we access 8? So how do we access 8? What row number is 8 located?
3.
Row number.
Row number is 1.
Yeah. So the row number is 1. The column number is
1 3.
1 by 9.
1.
1 by 3.
3.
Yeah. So that's perfect. So this is called indexing. So let me try to. So they call this index. Indexing means you want to get the index of a particular element. So where is it located? So to locate any element, you have to define the row, you have to define the column. But if the element is a vector, you only need to define one property. So let me give an instance. So let's say I have a vector like this, 1, 5, this, and all of that. I just need to define one property. I don't need to tell the row, the column. I can simply say 2. Just give me the one at position 2, which is 5. Then I can also say of 4. It's going to give me the one at position 4. I can also specify the full dimension. Like I can say row 1, column 4. It's still going to work because 7 is at row 1, column 4.
No.
You don't need to do that, but you can actually do that. Do you understand? Like you can actually do that, which will give you the right thing, or you can just skip that one and just go straight with 4. So that is for a vector. So the same thing goes to a cell. To get a cell, I can get any value by defining the row and defining the column. So row 1 column will give me this. The difference between, if you notice, the difference between a cell and arrays, you access it with a curly bracket. If you notice, in the previous example, we accessed it with a square bracket, with a round bracket. The indexing was done with a round bracket, whereas in a cell, the indexing here is done with a curly bracket. I believe this is clear enough. So 1, 1, but a curly bracket. You can actually use a square bracket. So let me just give you this example for a cell because this is very important. So let's say I have a name, then I have a value which is 80, then the next column, I have an array of 1 and 2, then I have something else like this. So this is a cell. The first row, first column is a string, and the string is down. For the second row, for first row, second column, 8.
Second column.
This is first row, second column, that's 80. This is an array, but a cell array, It is an array in a cell. This is the first row. This is the second row. The first row, first column is down. First row, second column.
Done.
Yes?
It's 80.
It's 80. Then the second row, first column is an array of 1 by 2, which is 1, 2. Then the last element is Jane. So the question is, how do we access, let's say Jane, for instance? If I want to access Jane, I can use the same idea. What row am I looking at? I'm looking at row 2. What column am I looking at? I'm looking at column 2.
Column 2.
Then I end with curly bracket, then enter. So the same idea is very similar to cell, but here's a difference. I'm going to save the answer here as answer 1. Then I'm going to use another approach to access it. The same thing, but I'm using a square bracket here. The difference, they're exactly the same. I'm still going to get Jane, but the difference is square bracket and curly bracket. So the question is, what's the difference between when you use a square bracket and a curly bracket for a cell data type? The answer lies in the class. So let's take a look at the class of answer.
Okay.
So let's take a look at the class of answer 2. You see the difference? Answer 1, the class is character, which is string, which is like, is a string data type. We expect it to be string because Jane is a string. Do you understand? Like it's a string of character. Why is the second one cell? Like the second one is cell, not string. Here's the difference. If you access a cell using a round bracket, the answer is a subset of that cell. And the subset means the answer will be a cell containing Jane. Hope you understand, like the answer is like a cell that has only Jane inside. So the difference is like this. The first one is this. The second one is this. That is the difference. Hope you understand, like the first one is just plain string. The second one is a cell. Inside the cell, there is now Jane inside. So that is the difference.
Yes.
So you have to be careful with that square bracket, a round bracket, and curly bracket. If you want to pluck out J or that element out of the cell, you want to pluck it out, use curly bracket. But if you want the result to be a subset of that cell, like the answer will be a cell containing only J, then go with the round bracket. So these two ideas are very key, because you may be seeing error and say, why is it not behaving like a string? I took out the J and it's still behaving like a cell. Yeah, it will behave like a cell if you use the round bracket. So that's one key idea you have to note when it comes to cell. So let's talk about slicing. We've talked about indexing. So let's talk about slicing. So what's slicing in programming language and in MATLAB? Indexing is when you just want to take an element. Slicing is when you want to take a group of elements, like a subset. So let's make, let me create a magic function. So there's a function called magic function in MATLAB. It creates a kind of random, not random per se, or it creates a kind of matrix where the sum of all the rows is the same thing as the sum of all the columns. But let me not go into details, but this is just a random, just picture as a random matrix. What if I want to get this region? Like I want to get from 32 down to 12. Like I want to get this middle. I just want to get from 32, 7, 21 down to 5, 32, and 12. That subset. How do we do that? So we call that slicing. So slicing is more or less like you are not taking an element. You are taking a snapshot of that matrix, like a subset of that matrix. So how do we go about it? So let's go this way. So you need to define the starting row. So we are starting from row 2. This row 2. So we are starting from row 2.
Yeah.
So we are going to type 2.
Row 2, column 2.
We are going to stop at row 5. So this is where we want to stop. I'm sorry, row 1, 2, 3, 4, 5. Yeah, row 5. We want to stop here. You understand? So 2 colon 5. So what you've just done is 2 colon 5 means 2, 3, 4, 5. That's what you just done. So colon is a shortcut for creating a range. Like 2 colon 5 is 2, 3, 4, 5. Comma. Now, comma means we want to type that of colon. We are done with the row. So for the row, for the colon, where are we starting from? We are starting from
2, column 2.
Column 2. And we are going to end here. So here is 1, 2, 3, 4. That's column 4.
Column 4.
So you end your bracket and you enter. Here is it. So we've gotten a slice of it. So this is slicing. So it's basically taking a subset of that array. And in most cases, you have either a matrix or a vector, not a single number. So this is slicing. Another thing you can do is, you can also achieve this by listing out the row. I can say 2, 3, 4, 5. I can say 2, 3, 4. So it's not a must use colon. Colon is just a shortcut for creating a range. Hope you understand. So this will give me the same result. I can also choose specific row that I want. I can say I want this row, I want this row. I can skip range. I can say, okay, I want to take row 1, followed by row 3, and followed by row 4. Then I want to take the following column. I'm going to get a result. So let's talk about math operation. So we've talked about slicing, indexing. So let's talk about math operation. You can do all basic math operation like plus, minus, division, but there's something called scale of preference. So let me just throw this to see how you respond to this. 2 plus 2 minus 2 divided by 2. What do you expect this result to be? Like 2 plus 2 minus 2 divided by 2. Like what do you expect the result to give us? The answer is 3. So let's talk about it. It's tricky, although it's not all that tricky, but it's about what they call preference.
It's 3, yeah.
So it's 3. So 2 plus 2
3.
minus 2 divided by 2. The problem is the order in which you calculate it can give you different results. So if you say 2 plus 2, which is minus 2, which will give you 2 divided by 2, that will give you 1. So that will give you 1. But if you use what you call board mass, you are going to get 3, because if I divide first, which is 2 divided by 2, that will give me 1. Then I do the addition, that will give me 4. So 4 minus 1, that will give me 1. So basically, this is how MATLAB, this is how MATLAB will compute it. MATLAB will solve this part, then solve this part, then solve this part. So this is how MATLAB will go about it. So the question is, why am I discussing this? This is the actual rule here is bed mass. So I understand that most of you understand board mass, but may I ask, has anybody heard about bed mass? Like BD, just change the O to E. Okay, in the world of computer, you use bed mass, not board mass. The reason is there is no off in computer. There is no off. Do you understand? Like there is nothing like off. So that O is out. Well, instead of O, we have E. So the E is called exponentiation. So the E is, so this is brackets. So this is exponentiation. Then you have division. Then you have multiplication. Then you have addition. And you have subtraction.
Subtraction.
Yeah. So this is bed mass. So what's exponentiation? We all know the rest, bracket, division, and the like. So exponential is power. So if I have something like 2 minus 2 plus 2 minus 2, then divided by 2 raised to the power of 2. So there's a problem here. Because there's raised to the power of 2, which comes first? Exponentiation comes before exponentiation. So it's going to deal with the power first.
That's
so, which means you get something like, let me run the answer.
2 plus 2 is 4 minus.
So this is what do we get? Then 2 plus 2 minus 2. If you do division, that will give you minus 0.5.
3.5.
Yeah, so that will give you 4 minus 0.5, and that will give you 3.5. So this is how it will compute.
3.5.
So that is the exponentiation. So it's very important to know that, because the way you type the program, you may type it in a way and it means something else. If you mean something else, use bracket to control it. So let's say maybe what I want in reality is to do this exponent after this division. Then you better put it in brackets. Hope you understand. Like if you want the exponent to cover the division, like everything after the division, then put that in brackets. So bracket will come first. It's going to solve the bracket first. Do you understand? So it's very key you get all that, because I've seen cases where someone will say, well, this code is not working. And the problem is they failed to understand the order of preference, like how the program will execute it. So eventually they did not put it in bracket and things got messy. So it's the same thing when you want to do, let's say, quadratic equation. You want to use quadratic equation formula. We know it is minus b plus or minus square root of blah, blah, divided by 2a. That divided by 2a, if you don't put the 2a in brackets, you're going to get a different output. Like, let's say I have something like 2 minus square root of, let's say, 4 plus 3, then bracket 2 times a. Let's say a is 5. If I do it this way, I've done something wrong. Like, what will happen is it's going to solve the square root. Then it's going to divide by 2 alone. Then after dividing by 2, then multiply the entire result by 5 before subtracting from 2. So if this is not what you want, you may want to put this in brackets, maybe everything here in bracket, then put everything here in bracket. You understand? Because now you have actually created denominator and numerator. So this is your numerator, then this is your denominator. If you don't put the entire denominator in bracket and you don't put the entire numerator in bracket, you are going to get a very different result. So it's very important to understand bracket is used to create preference, like do everything in this bracket as a whole first. Then exponentiation comes next, followed by division, multiplication, addition, and so on. Okay, so let's talk about other math operations. So there are so many math operations. You can look for the cosine. Note that when you type cosine of something, that cosine is not in degree. We all know that cos 60 in degrees is 0.5, but the degree in this case is radian. The default angle is radian. Hope you understand my point. Like cos 60, which we know is in degree, is not the same cos 60 here. Because 60 here, your 60 is in radian. So if you want to get the right answer, convert your 60 to radian. So if I want to get cos 60, I can convert to radian by multiplying it by, if I multiply by pi and divide by 180, then I've converted it to radian. So that will give me 0.5.
Degree.
The 60 degree, to convert from radian, from degree to radian, multiply by pi, divide by 180. So 60 degrees is equal to 1.047 radian. But the answer is not in degree. The unit of cos is not degree. It is the angle that you pass into it that is in degree or radian. Hope my explanation is clear. So the 0.5 is not degree or radian. Cos of an angle is never in any degree or radian. It is the angle that is either in degree or in radian. Okay, so I think there is a function for degree components. I think MATLAB has cos for degree. If you want it to operate in degree, you have to say cos D, like cos, attach D to it. Then the inputs will be accepted in degrees. So this gives you the right answer. Okay, so we have trig, we have log, we have exponent. So I can say log of 200. Then I can say log in base 10. The normal log, this log of 200 is log to base E. But if I want it to be in base 10, I have to say log 10. So we know log 100 to base 10 is 2. I believe you are following. So this is log 100 to base 10. So if you want to be in base 10, you put log 10. But the other alternative is base E. And which other thing? Exponent. If you want e raised to the power of, let's say, anything, you type it this way. So this e raised to the power of 4. So this e raised to the power of 4. So which other function? You can get a lot of functions by searching MATLAB help. Like if you want to get more functions, there are hundreds of them, maybe even up to 1,000. If you click on this function, this FX arrow, it will pop this documentation. You can search for as many functions as you want, elementary maths, we have arithmetic, trig, exponent, log, descriptive statistics, and so on. There are so many functions you can use. So let's play around with other functions like mean, median, and mode. So let's create an array. I'm going to create a random array. If you want to create a random array, an array whose value is between 0 and 1 randomly, just call rand. Then tell the number of rows. The number of rows 4, the number of column 3. This will give you a random array. It's just like you generating random numbers between 0 and 1. So what I want to do here is I want to take the sum and I want to take the mean and so on. So let's look for the sum of A. If you look for the sum of a matrix, you'll see what happened. Like what has happened here is it has collapsed everything based on, okay, let me come up with something much better. So let me come up with something we can easily see for ourselves. So let's take the sum of A1. So what happened here? It took the sum colon wise, like it summed each colon. 1 plus 4, that's 5. 2 plus 6, that's 8. 3 plus 7, that's 10. But there are times that you want the summation to happen row wise, like row by row, not column by column. So in that case, you will specify that
617.
You want it to happen row wise by specifying 2.
617.
If you put 1, 1 is the default. 1 means column wise. 2 means row wise. So we call this extra parameter, this extra information axis. What dimension, along what dimension do you want to sum? So if you say 1, it means along the column. If you say 2, along the row. So that is how it works. So it's 6 and 17. Then if you want to sum everything, okay, if you want to sum everything at once, then you can take the sum twice. That is, you can take the sum twice, like sum of the sum. So that's one way you can take the sum. But there's another strategy which I'll talk about later, which is like reshaping and all of that. But let me leave that aspect. So this is the sum. You can look for the mean. This is the mean. The same thing applies. It will take the mean column by column. If you want to take the mean row by row, you specify that you want to take the mean row by row. So that's the same thing. So we have mean, standard deviation, and so on and so forth. Okay. So the next thing I would like us to talk about is modulus. So how do we take modulus of a number? So how do we take the modulus? 3 modulus 2. Like what is something like 3 modulus 2? Like can I get a response? Like what do you think the answer would be if you take 3 modulus? So I want to know if you understand what modulus is, because we will definitely come across it down the line.
1.
Okay, yeah, 1. That's correct.
1.
So, yeah, that's correct. So modulus is simply the remainder when you divide A by B. So if I divide 3 by 2, what's the remainder?
No.
So the remainder is 1. It's more or less like if you take multiple copies of 2 out of that number, what will you be left with? So the remainder in this case is 1. So in MATLAB, you can get modulus as follows. Mod 2, 3, 2. So this is the function for getting modulus. So obviously, 6 modulus 2 will be 0. Then if I have 11 and I have this and I want to get modulus, the modulus is 9. So 9 means if you divide that number by 11, the remainder you're going to get is 9. If you divide completely, so the remainder will be 9. Okay, so that's modulus. What else can we do? We can look for the absolute value. So let's say I have a number like this. So I have -2, -1, this, -5, 8. I can look for the absolute value of this. So the absolute value we strip away all the negative value, just turn them to positive. Then I can also look for all the sign of A4, like sign meaning I want to know which is positive and which is negative. So it's going to give me, the first one is negative, that's -1. It's not going to tell you the value. It will just focus on -1 for negative, 1 for positive. Hope you understand. So that's what it does. So it's like give me the sign of each element in that array. So That's fine. There are many other functions, and we're going to come across them as we proceed. So which other thing do I want to talk about? I want to talk about Boolean operation. I'll be wrapping up in the next, let's say, 5 minutes or so. So let's talk about Boolean operation. So what's Boolean operation? Boolean operation, they are just operation that allows you to arrive at true or false. So I'm going to look at, most of us must have come across this. If I have a true statement and I have a false statement, if I use and or, we know what the answer should be. Okay, let's say B1 is true and B2 is false. So B3 is B1 and B2. So what do we expect the outcome to be? Just like saying true and false will be equal to what? Like true
False.
and false will be false. Why you have zero is
Zero.
you understand? Zero represents false, one represents true. But you need to know the notation here. So the notation is and. You use this upper sign or so for and. Then you use this vertical line for or. So this is or. Do you understand? So this is the or sign. Then do you know why it's true? Because true or false is equal to false. You know, if any of them is true, sorry, it's equal to true. If any of them is true, when you apply or, it will be true. So that applies. Then what about negation? You can negate something by just using this. This I think is called, is it either sign or something like that. If you put this sign in front of any of them, you are getting negation. So B1 is true at the beginning, but if you negate it, it becomes false. Then the one that is false becomes true. So this is how you negate Boolean operation or Boolean data type. So let me just recap. Let me just recap what we've just done so far. We started with intro to MATLAB. We talked about data types, which include our double, our integer, our string. Then we talked about Boolean. Then we moved into array. Array, we have two types, vector and matrices. Then we talked about structured data type, where we said you can have a kind of sub variable inside a particular variable. Then we talked about cell type, where you can have heterogeneous data type. Then we talked about indexing, slicing, math operations, or matrix manipulation, and eventually Boolean operation.